The following video is intended to enable one to make the best use of a Marina Photonics PV16 amplifier discriminator, or as it actually is, a limiting amplifier with variable gain. The bottom two traces consist of the output of the PV16 in trace 3, the gold trace, and trace 4, the blue trace. It has complementary outputs. The top trace is the analog output of a Hamamatsu hybrid photomultiplier tube amplified by two cascaded amplifiers totaling about 60 dB. The slight undershoot after the positive peak is due to the inductor in the first amplifier, as this is not set up to be optimum, it's just set up for illustration. The bias voltage on the APD is 390 volts now, and when I turn off the 8,000 volt supply there will be a huge burst of noise. It takes a while for it to settle. It can take up to a minute or two for it to settle depending on how the power supplies are put together, but you see no false pulses or noise on the output of the APD, on the output of the PV16, as long as there's no noise on the output of the hybrid tube. An interesting characteristic of the hybrid tube is that turning off the APD voltage, as I do now, allows the voltage to drop and changes the output impedance of the APD on the hybrid tube. Now we're getting lots of false signals. The APD has been biased to 0 volts, or basically turned off. The point of all this is you want to make sure that you set the bias levels such a point that there's no real noise coming out of the hybrid tube before you set the threshold level for the PV16. The PV16 has enough gain to see signals out of the Hamamatsu tube at approximately 380 volts bias, so it has a lot of headroom, and so you don't need to crank it all the way up. I'll turn the APD voltage back on again. There'll be a big burst of noise. Well, the burst of noise didn't show up, but the PV16 output has now disappeared. I'm going to crank the voltage down on the APD so I can determine what point it begins to get noisy. We're down to 285 volts. $250 volts and 200 volts. 200 volts, we still have low noise coming out of the APD. At 50 volts, we seem to have quite a bit of noise coming out of the APD. So I'm going to go up to 75 volts. At 75 volts we have some noise, but not a lot. I'll go down to 30 volts. At 30 volts you have quite a large amount of noise coming out of the APD. This illustrates the point that the APD must be biased for its impedance to turn on to the point where noise is lower. So more voltage produces less noise up to a point. Here's 150 volts, so that's pretty good. So I would say that if you go up to at least 200 volts bias on the APD and set the PV16 so that you don't get any false output pulses, because there's still noise there, as one can see on the top trace, then you've got the threshold set fairly well. Now I'm going to crank up, turn on the high voltage, and I'm going to crank up the APD until I begin to see pulses. As I turn up the voltage on the APD, I'll begin to see noise pulses because the power supply takes a moment to stabilize. I'm now at 337 volts and it's all is quiet on the western front. Power supply takes a while to stabilize as I'm adjusting it. At 378 volts on a split signal, I'm beginning to see some photon pulses, but I'm not getting them all. I have a 532 nanometer 1 angstrom filter, so I'm just looking at room light, and there should be more pulses than that. So I'm going to go up to 385 volts. So at 385 volts, we're getting lots of single photon pulses, and cranking the APD voltage up much higher will not produce an increase in rate. This is perfect setup for counting photons. Not too wide, and yet still no noise. If I crank the voltage up to 400 volts, notice that the PV16 pulse width is much wider, but the output amplitude is still the same. You haven't really lost anything because it's still about 1 nanosecond wide, and it's not likely you're going to get pulses that are 650 or 700 picoseconds wide piling up on each other in that amount of time. However, it is possible to reduce the threshold here by turning the gain down, that is, turning the pot counterclockwise to restore the pulse width to the nominal photomultiplier pulse width. As you see here, I'm getting about 300 to 600 picosecond pulse width. I'm going to crank the voltage all the way up to 419 volts. And once again, the pulse width gets a little bit larger. That's because the base of the pulse is wider. The rise time and fall time are not zero. And I crank the gain of the PV16 down again, and I can get the pulse width less than a nanosecond. So this is how to adjust the optimum pulse width for various voltages. It may be that the system is so noisy that one would have to run your hybrid photomultiplier at the maximum gain to be able to make maximum use of the PV16 because of intrinsic signal-to-noise ratio in the system as opposed to signal-to-noise ratio in the Hamamatsu photomultiplier. Alternative adjustment method. Let's assume that everything is working fine and there are no output pulses from the PV16. In this case, I've set the voltage of the Hamamatsu tube to be 8,000 volts, minus 8,000 volts, and 400 volts on the APD going into the PV16, split by 2, by the way. So what I'm going to do is adjust this for what I think is optimum threshold. Now we're getting a very narrow pulse on the bottom trace. I'll expand that a little bit. This is 500 picoseconds per centimeter. So we're getting less than a 500 picosecond wide output pulse from the PV16. This shows the very fast rise time of the device, by the way. As I increase the gain on the PV16 amplifier, I begin to get pulse widths that begin to look like they're greater than 500 picoseconds. Cut the time base down again to a single shot. Let's try a better shot. Okay, so we see that this is 647 picoseconds on the top and 500 picoseconds on the bottom. So I'll turn the gain up just a little bit more. Turn it down a little bit. And we're getting close to having the same pulse width for the top pulse and the bottom pulse. This is the alternative way. You start out with everything turned on, the gain on the PV16 turned down, and crank the gain of the PV16 up until you see pulses. This of course assumes that there is no output. You should not have any output whatsoever when the gain is lower than the threshold of the hybrid photomultiplier output. One way to check that is to crank the hybrid photomultiplier APD voltage down to about 300 volts. At 300 volts, it's most likely that even the 63 to 64 dB gain of the PV16 will not see any output. I hope this has been helpful. If you have any problems, feel free to call Marino Photonics.